All right, guys, so I have another question here on the Mastering Chemistry Solid Liquid Intermolecular Force assignment, question number 18. I'm just going to go ahead and go over parts A, B, and C. So part A, how much heat is required to melt 58.5 grams of ice at its melting point? Key word here is melt. At melting, when we have our heating curve, melting occurs here. That's our plateau. Remember, we use Q equals MHF. So we're going to use the mass times the heat of fusion value for water, H2O, because this says ice. So that's our H2O. All right, so the mass that it gave us is 58.5 grams. Then the heat of fusion. So we look at our yellow chart. We find water. Heat of fusion is the second column. Heat of fusion for H2O is 334 joules per gram. Since it gave me grams, when I multiply joules per gram times grams, I'm going to be left with joules. I notice that some of these other ones have kilojoules per mole and other stuff. What I want you to think about is if you have one of those, make sure you convert your grams to moles first prior to solving, because then otherwise you're just going to have a jumbled mess. All right. So times our heat of fusion of 334 joules per gram. So all we have to do is type that in our calculator. So I have 58.5 times 334 equals, it's going to equal 19539 joules. I know on mastering it's asking you to give them a value in kilojoules. So we just have to move the decimal 3 places over. I think it wants 3 sig figs, so 19.5 kilojoules would be the appropriate answer. Part B, how much heat is required to raise the temperature of 58.5 grams of water from its melting point to its boiling point? So here we have our heating curve with all our phases. So here is our freezing point of water is 0 degrees Celsius. And we have here boiling point, which is 100 degrees Celsius. All right, because this is on H2O, water. So it says from our melting point to our boiling point. So it just wants to know how much heat's required to raise liquid water from 0 to 100 degrees Celsius. So since we're on a diagonal, we're using Q equals MC delta T. So Q equals MC delta T. The mass is our 58.5 grams. C is the specific heat of liquid water, since we're in the liquid phase of this chart. Here we have our solid, here was liquid, here's our gas. All right, so we go over here. Water, specific heat is this column here. Water liquid specific heat is 4.184. Go back over here. 4.184 joules per gram degree Celsius times, and then our delta T is our change in temperature. So our change in temperature again was from our melting point to our boiling point, so 100 to 0, right? So 100 minus 0, or 100. We're going to type that into our calculator to get our Q value. So 58.5 times 4.184 times 100. And that gives me a Q value of 24476.4 joules. We need to think about our significant figures. So we're looking for 3 sig figs. So we need these numbers. This is going to bump that 4 up. But we also need it in kilojoules. So to get kilojoules, we're going to divide this number by 1,000. So we're going to get 24.5 kilojoules as our answer. All right, part C. Part C, how much heat is required to boil 58.5 grams of water at its boiling point? Key word, boil, right? So when we have our heating curve, boiling point, right? Our heating curve, this right here is our phase change. This is our boiling. So Q equals MHV was our equation for that. Mass times our heat of vaporization. So the mass is 58.5 grams times, and our HV value. So we have to go back to our yellow chart. Heat of vaporization is this column right here. So for water, our heat of vaporization is 2,260 joules per gram. So we come back over here. So 2,260 joules per gram. We're going to multiply this. So 58.5 times 2260 equals. So our Q value is 132,210 joules. And our mastering assignment wants it in kilojoules. So we divide it by 1,000, right? So 132 kilojoules is our answer. So I hope this information is helpful for you for mastering question number 18. Please feel free to send me an email if you have a question on anything that we just went over. All right, thank you. Bye.